But we're going to practice the equation of the circle. And then right after the equation of the circle, I said I would practice this homework page. I actually might change my mind on that, and I might jump right into completing the square. So we'll take a look at that as well. And then we'll look at examples of completing the square, because I think that's going to be... Don't change my mind. You want to do the practice? I might assign it, though. I don't know. We'll see. We got 3 examples to do before we get there. But I definitely want to get to completing the square, because there's definitely a lot to do there, because I think that would translate very nicely into Monday. We can practice completing the square, and we can see how completing the square is going to tie into the equation of a circle. But let's jump right to it. So, big thing yesterday, there's really 2 major things about the equation of... Have I heard of Space Force? I believe so. But the 2 major things with the equation of the circle are the fact that here's the general form of it. This is like the y equals mx plus b, but for circles. And there's really only 2 major properties for circles, which are the coordinates to the center, which are h and k. You got to flip the signs. You just got to go back and forth between positive and negatives if you're going back and forth between coordinates and actual plugging into the equation. That's kind of the first thing you need to look out for. And then the radius. The equation is set equal to the radius squared. So you do need to square root or square when going back and forth, depending on which direction you are going. So that's kind of the 2 major things to look out for. And you know, in any problem, always kind of try to, any way you can figure out the radius would be fine. So here in number 2, 18. When the x-coordinate is by itself like this, we see just an x squared. There's no parentheses or anything. This is for us to imply that the x-coordinate is going to be 0. Because there's nothing else to suggest that there's in parentheses or anything like that. So the x-coordinate is 0. And then the y-coordinate, because it's positive 10 in the equation, we flip the sign and it's going to be negative 10. Now we need to figure out the radius, and this is r squared right here. R squared is 42.25. And like I said, find the radius first, then the diameter. Don't double this and then square root it. You don't want to do that. You want to square root it right now to figure out the radius. So when you square root this, I'm just going to throw that in a calculator really quick. 42.25 square rooted. Oops. I think it's 6.5. It is. It's 6.5. So r equals 6.5. That's the value you can go ahead and double. You'll notice if you double the 42.25, then square root it, you're not going to get the same answer. You're not going to get what you're supposed to get, which is 13. So the diameter is 13. And the last question. We just got to flip the signs. So we see negative 6 for that x-coordinate, so it's positive 6 for the actual coordinates. Then y plus 11, therefore the coordinate is negative 11. And then the radius, well, this is 58, so it's r squared equals 58. And then you're going to square root both sides. So the radius is the square root of 58, which we could plug into a calculator to get an approximation for it. Usually you don't need to. I'm fine with square root of 58, which I think is in simplest radical form. I'm not 100% sure, but you could also plug into a calculator. You get about 7.6 for a radius. And sometimes having the decimal number is helpful, especially if you are graphing it. Obviously, graphing decimal numbers is not going to be ideal, but it's something we could consider. And like I said yesterday, this skill, what we're doing right here in 16 through 19, is going to be an important skill that we're going to utilize a lot. All right? All right, we can do this challenge problem now. The challenge problem says, write an equation of a circle with a diameter endpoints of negative 14, 1 and negative 10, 9. Now, we don't need to graph this. but I'm going to just draw a picture of kind of what this would look like. So it says negative 14 and 1, so that could be somewhere over here, and then negative 10, 9, which I don't really have it drawn on the scale because we don't really know where the origin is. I'm just going to put two arbitrary points here and here. I know this is not an accurate description of kind of what these points would look like and where they would be on a graph. But one thing we know is that these endpoints are the diameter of the circle. And in the equation, the question is find the equation of this circle, and the diameter has these endpoints. And that's what we're going to need to figure out. So remember the two things that you absolutely need in order to figure out the equation of the circle. The two pieces of information you need are the center of the circle and the radius of the circle. Knowing the coordinates to the endpoints don't give you either of these information, either of pieces of this information directly. So we're going to have to do a little bit of equations, plugging in, figuring out where both of these things are. First and foremost, there's a number of ways you could do this. You might realize, well, if you have the diameter, you could find the distance of the diameter and cut it in half, and then you'd have the radius. So the radius should be under control. What about the center of the circle? Well, you should agree that the center of the circle is halfway between the diameter. That's the center of the circle. And we have a very good formula for us to figure out exactly the halfway point. Abby just said in the chat, the midpoint formula. We haven't used it in a very long time, but we absolutely could figure that out. If you ever forget the midpoint formula, your best bet is to just graph it. But it's a pretty easy formula. So in this case, the midpoint is, it's the x coordinates. I'll write out the formula. x1 plus x2 divided by 2. It's a literal average. And then y1 plus y2 over 2. You can also intuitively figure it out. Look at the two x coordinates right here, negative 14 and negative 10. What's the number directly in the middle between negative 14 and negative 10? It's going to be negative 12. And the math will show it to you, and I think you could figure it out intuitively for yourself. So negative 14 plus negative 10 over 2, which is negative 24 over 2. That's negative 12. And then what number is directly in the middle between 1 and 9? Should be 5. That's the number directly in the middle, because 1 plus 9 divided by 2 is 5. So the midpoint is negative 12, comma, 5. That's the center of the circle. So we found one piece of information that could help us figure out the equation of the circle. Now we just need to figure out the radius. And like I said, now you have three coordinates you can play around with. You can figure out the distance of the actual diameter and then divide by 2. But now that you actually know the center, we can do what we've done earlier. Just do from the center to one of the endpoints. Now, best thing is, it doesn't matter which endpoint you choose to use. If you use from the center to either one of those points, negative 14, 1 or negative 10, 9, you'll get the same exact distance, assuming you've done the calculation to the midpoint correctly. So I always opt to use whichever one I think is easier, and I think negative, they're both kind of easy. So really doesn't matter. I'll go with the negative 14, 1. So the distance. So I'm going to use negative 14, 1. The only thing you got to make sure, don't mix up. Don't use like one coordinate from one and then another coordinate from the other. Just stick with one. So I'm going to go with the negative 12, 5 and the negative 14, 1. So it's negative 12 minus negative 14, close parentheses and square it, plus 5 minus 1 squared. So we get negative 12 plus 14 is 2, and 2 squared is 4. 5 minus 1 is 4, and 4 squared is 16. So we get the distance is the square root of 20, which is r. Again, don't confuse that lowercase d with a diameter. We are using that letter for the distance, which in this case is the radius. What packet is this in? It's the same exact packet we've been using. Yeah, it's perfectly fine. If you did the distance using the diameter, you should get, I want to say you get the square root of 80. If you did the diameter, I think you get the square root of 80. You can check to see if I'm correct or not on that, but just double check. If anyone did that, they can double check me on the diameter being 80. And again, I'm using the letter D, so I'm actually just going to write out diameter. Diameter equals the square root of 80. Just be careful when you're finding the diameter and you divide it by 2. If you divide this by 2, it is not the square root of 40. Just be careful. Wait, where did the 16 come from? Then you got 2 radical 5. Is 2 radical 5? Yes, 2 radical 5 would be correct. That's good. I got it from here. The 5 minus 1 from my distance formula. Let me double check. Yep, the 5 is the y coordinate. 1 is y coordinate. So I did 5 minus 1. That was 4. 4 squared was 16. I personally think it's better and easier if you just directly do the distance with the center of the circle to the radius. You'll avoid this mathematical problem. It's just an extra chance of making a silly error. Because a lot of people will divide the square root of 80 by 2 and say, oh, that's the square root of 40. You can't divide whole numbers and square roots that way. Doesn't work. Even though, because I mean, look at the difference between these values, square root of 20 and square root of 80. That's 4 times away, which is typically what we'd see. Because when you plug back into the equation of the circle, you do need to square it. So the correct answer should be x plus 12 squared plus y minus 5 squared equals the square root of 20 squared, which is 20. If you did the diameter and like Paige, you did 2 rad 5, when you square 2 rad 5, when you square this whole thing, you should get exactly 20 as well. If you're doing it that way, because then you have to square the 2, which is 4. You square the radical 5, which is 5, and 4 times 5 is 20. So we kind of went up, we kind of simultaneously went under 2 different avenues for this problem. But hopefully you see that just finding the radius directly is easier. But if you really know what you're doing, it shouldn't matter. And that's the equation of the circle. Then we get to this page, which I'm going to hold off on this for now. I might assign this next week. I don't know yet. Maybe I'll assign a weekly. I don't know. Because I know we didn't have an assignment this week, so we'll definitely have one starting on Monday. I just don't know which one that's going to be. So I'm going to go right into completing the square. So what does it mean to complete this square? So you might remember this. It's a method of factoring. So what does it mean? It's a method of factoring where both factors are the same. That's the important piece with completing the square. You want both factors to be the same. And what I mean by that is when you're doing your two numbers that multiply into something and then two numbers that add into something, you want the same number in those blanks, like 5 and 5. Not 5 and negative 5, but positive 5, positive 5. Or 4 and 4, negative 2 and negative 2. The goal is you want the same two numbers in those blanks. And that's what completing the square is going to allow us to do. So it says give an example on a square. So the factors would look something like x and, I'll use 5 again, so it's x and 5, x and 5. And then you could do your box method to see what this looks like. X squared, is it 5x, 5x, and 25. So it would be x squared plus 10x plus 25. And why is this important? Because if both factors are the same, if we take this expression that I just wrote, if we were to factor this going backwards, well, we know the factors already. They're x plus 5 and x plus 5, right? Two numbers that multiply into 25, two numbers that add into 10. We know it's 5 and 5, which means the factors are x plus 5 and x plus 5. And the reason this is going to be important, if they're exactly the same, it's an expression multiplied completely by itself. Well, what that means is it is x plus 5 squared. And that form right there should be a little bit familiar, and how this can easily lead into the equation of the circle. Because if the factors are the same and we could always get kind of a result that looks like this, well, that's starting to look a lot like the equation of the circle. Look at all your x values and your y values. It's always been something in parentheses, and it's got that square on the outside. So this is why completing the square is going to be important. Now how to actually do it. So we're going to do an example with a positive coefficient on the x term. So I'm just going to make up an expression. Actually, I just want to see my next page really quick. An equation. Okay. So I'm just going to make up an expression here. I'll do x squared plus 6x. We're going to go through the steps on how you're going to complete the square. So it says in step 2, you're going to take the number from, we're going to take the number from step 1, we're going to divide it by 2. We're going to take the b term. So they are talking about the b term here. And the b term, it's following your regular quadratic, your ax squared plus bx plus c. You'll notice there's no c term right now. We're just calling it 0. Which is fine. But we're going to take the number from step 1. We're going to focus on the b term. The b term is always the number in front of the x. We're going to take that number and we're going to divide it by 2. And then we're going to square the quotient. So what this means is you're going to take 6, you're going to divide it by 2, and you get 3. Then it says square that number. So we're going to take 3, and we're going to square it, and you get 9. And we're going to see what we're going to do with that number. Step 3 says add the number from step 2 to your original expression. So the original expression is the x squared plus 6x. So we're going to do x squared plus 6x, and we're going to take this number, 9, and we're going to just add it to the original expression. So we get 9. So we're just adding plus 9 to the expression. Then in step 4, it says factor your trinomial. So we're going to factor it using our traditional method. So two numbers that multiply into 9, and then add into 6. Pretty easy one to factor, should be 3 and 3. Notice, when we're completing the square, You always get the same numbers in all those blanks. That's kind of the whole point. Because now you get these nice factors. You have x plus 3 and x plus 3. And step 4 just says simplify, because look at the previous step. You have two x plus 3's being multiplied together. So it's x plus 3 squared. And if this were an equation of the circle, this would tell you the coordinate, the x coordinate, would be -3. So you can see how this is going to tie into the equation of the circle quite easily. Now that's not a new process to you. You've seen this last year, or should have. And I know you have, because I know Ms. Keener does teach it to you. I am just a little curious if she teaches it in the same exact way. I don't know. I know for the most part it is pretty much always the same. It's always that b term, divide by 2 and square it. I might do some things a little differently, but that's usually always the method of completing square. Divide the b term by 2 and then square it, which is a lot of this step right here. That's the step that we're going to really need to utilize in order to complete the square. We're going to get really good at it because there's a few tricks we can, and a few patterns you might recognize when completing the square, where you're going to be able to do this very, very quickly. It seems like a complicated process right now, but it's actually really, really easy. Because we're going to do so many of these, and we're going to just pick up on those patterns. And if you're here in the stream paying attention or rewatching these videos, and you're not skipping over anything, you're going to pick up on how easy these can be. She does something almost completely different. Unfortunately, I can't see how. No one can show me. But there's a reason why I'm doing it this way. And like I said, it's going to make our lives a little bit easier as we do more and more examples. We're going to pick up on some patterns in which that is. Let's take the negative. We're going to do another example, but with a negative x term. So we're going to do x squared minus, I'll do 8x. We're going to follow these processes exactly the same. We're going to take that b term, which is a -8. So you're going to take -8 and divide by 2, and you get -4. Then you're going to square that. Now just be aware, when you square -4, notice I put it in parentheses, because when you square a negative number, it will become positive. Which tells me that regardless of positive or negative numbers, that number that I have highlighted right there will always be positive. You should never have a negative value for that highlighted piece right there after you square it. The other piece can be negative, that's fine, but not that number right there after you square it. Then step 3 was add that number to the original expression. X squared minus 8x plus 16. Factor like normal. So two numbers that are going to multiply into positive 16. Two numbers that add into -8. These factors are going to be -4 and -4. Again, the whole point being all four numbers in those blanks are exactly the same. If you're factoring your traditional way and you get two different values, you've probably done something wrong. So your factors are x minus 4 and x minus 4, which is then x minus 4. Whoops, I should be writing this in the last blank. X minus 4 squared as our final answer. And possibly one reason why this looks different is because I'm not doing this with equations. We are going to have to do this with equations, which is what the next page is going to look like. And that's how we're going to be utilizing them when we're looking at circle equations, because it's in the name, circle equation. So there's going to be an equal sign. Right now I don't have an equal sign, which kind of is a little bit of a problem. Well, if there's a C term, we will absolutely get to that. We'll get to what happens when there is a C term. We can still complete the square, but we're going to have to do a little manipulation with that c term. So we're going to take a look right here, and then we have lots of practices. You'll see that in some of these there are c terms, and I think, like right here, number 5, there's a c term right there. We'll definitely learn how to handle when there is a c term. All right, so solving a quadratic equation by completing the square. So I'm going to write out an actual quadratic. I'll do x squared if there was already a c term present, would we just add the b term after we divided by 2 and squared it, because technically the b term becomes the c term? Yes and no. So your explanation is partially correct. And when we do the negative, maybe I can just add a b term right here. Problem is, I don't know if, because we are now going to solve using quadratic equation, and I just don't know if I can think of one off the top of my head that's going to work very nicely. I'll try. I'll do minus. Do I want to do minus 8x? Equals I guess I could do plus 16. Problem is this factors already, so I don't want to do that. I'm just going to keep it. I'll do this. So now we will see it with a c term. Again, I'm not 100% sure if this will work as expected, but I'll try my best. Because now we see the c term. Step 2 says make sure that the coefficient on your x squared term is a 1. So that's important, that this right here is a 1. If it's not a 1, you're going to have to do a little bit of manipulation to figure out how you're going to make it a 1. Like if there was a 2 in front of there, you probably have to divide everything by 2 in order to get a 1 in front of there. And what I'm going to do, because now we have the c term, and our steps over here actually don't tell us how to handle the c term, what we do is you're going to take the c term and you're going to put it on the right hand side of the equation. So we do have a 1x squared, we have a minus 10x, but we're going to subtract 16 from both sides. You actually don't want the whole number there. So I'm just going to throw it over here. So you get negative 16 over there. Then step 3 says find the number that will complete the square for the x squared and x terms, which that's basically the b term divided by 2, b over 2, and then square it. So we're going to take the b term, which in this case is the number in front of just the regular x term, which is negative 10. So we're going to take negative 10, we're going to divide by 2, and you get negative 5, and then you're going to square negative 5, and you get 25. That's the number you're going to want to add to the equation. And here's where you see it in step 4, which we did not do in the previous page, because in the previous page it wasn't an equation. There was no equal sign. But now that there's an equal sign, we have to add 25 to both sides of the equation. So now it becomes, so here's the equation right here that I'm adding 25 to both sides. So it's x squared minus 10x. Then you need to add 25 to this equals negative 16 plus 25. So you have to add it to both sides of the equation, because That's one of the fundamental rules of algebra. Whatever you do to one side of the equation, you have to do to the other. So the left-hand side, and the reason you wanted to get rid of that negative 16 in the first place was because you do not want to combine like terms, because this is the expression that is going to factor the way we want it to. If you combined like terms, if you kept the 16 over there, it all of a sudden wouldn't factor like we wanted. But now we can factor and simplify our trinomial. We can combine like terms on the left-hand side, though. So I'm just going to combine like terms over there. Negative 16 plus 25 is 9. Now, step 5, factor your trinomial and simplify. So two numbers that multiply into 5. Sorry, not 5, 25. And two numbers that add into negative 10. Which is negative 5 and negative 5. Now, a good little trick about completing the square, and I haven't mentioned it yet. I'm going to highlight this number up here. It is always whatever when you did your b divided by 2, it is always that number. Every single time. If I look at the previous examples, remember when I divided this by 2? It was 3. Notice what the factors were. This is why I say you'll be able to do these really quick when you pick up on this pattern. You divided b by 2, you got negative 4. Those were the factors. This happens every single time. This is one of those little tricks, so you don't need to really figure out what number it is. You already know what it is. So that's why I like to highlight both those numbers, that 3 and the 9. The 9 is what I add to both sides. The 3 is what the factors are going to be. So no surprise why we're getting negative 5 for both of these factors. So this becomes x minus 5 equals 9. And just simplifying it, it's x minus 5 squared equals 9. Which, for the sake of what we're doing, this is what you need to be able to do up to. The bottom two is going to be the part where, if you were in algebra, you would likely then start solving these equations. Our goal is to get it in this form, like this x minus 5 squared equals 9, because that's starting to turn into the equation of the circle. The only thing we're missing right now are those y terms, which is what we're going to start doing next week. If you were solving it from here, if you were in algebra, you would take the square root of both sides. And if you remember from algebra from last year, whenever you take the square root of a number, you have to consider the positive and the negative. So it would be x minus 5, because that square cancels out the square root. So it would be x minus 5 equals positive 9, and then another one, x minus 5 equals negative 9. Because there are going to be two answers, because this still is a quadratic. And then you could solve from there. X equals 14. Add 5 to both sides, you get x equals negative 4. But that's what you would have to do if you were in algebra. If I asked you to solve using completing the square, you just have to do that extra step. But once we hit step 5, for our geometry purposes, we'll be done once we reach that step. And then step 7 just says check your solutions, meaning plug back into the original and make sure that they work. I'm going to skip that. I'm not going to worry about checking it. Because, again, we don't really care. And that actually worked out pretty nicely. I guess I chose two numbers that worked out pretty well. Shouldn't it be 3? Probably. Oh, yeah. Sorry, these should be 3. Maybe I should have checked my solutions. So this would be 8. That would be negative 3, and this would be 2. Right? Positive 8, and then positive 2. Yep. Yes, because I had the square root of the 9. So it should be 8 and 2. Which you can check that into the original equation and so forth. And you'll notice one thing at the top of the notes. The direction, it did say for a positive coefficient in front of the x term. We actually did a negative. Again, that was because I just chose one. I just made one up on the spot, so I kind of neglected that. So you can just cross that out and write negative, and then tomorrow we can do a positive one instead. But they do take a little bit of time, so, and I know we got 2 minutes left, but I think this would be a good spot to end. We'll take a look. Again, we're going to be completing the square on Monday. We're just going to practice it. Got a bunch of examples that we're just going to practice completing the square until we get really good with it. Because realistically, when we start using the circle, you're going to have y terms in there as well. And that's something that we are going to have to deal with. How are we going to do it with x terms and y terms? And you see whole numbers kind of everywhere. You see a 5, I see a 25. And that's kind of what we're going to be learning to do. I'm pretty sure there's a typo in this one already that I can see, but we'll handle that when we get there. But hopefully you're starting to see, why are we spending time on a lot of time on an algebraic topic? It's going to tie very nicely into the equation of the circle. All right. But that's going to end that ends our week. You guys have a nice weekend. And I will, can I link my YouTube channel? Yeah.